Hello friends, today we are going to focus on analysis of beam and frames manually and using Etabs software. We are going to calculate axial force, shear force, bending moment and draw axial force diagram, shear force diagram and bending moment diagram. Let us consider a simply supported beam as shown in figure. Here support A and support B are hinged and 300 kN load is acting at C, i.e. mid of span of length 0.84 meter. Using equilibrium equation, summation fx equals 0 along x direction, summation fy equals 0 along y direction, summation moment equals 0, we will find the reaction and moment for the structure. For this, we are going to calculate reactions at support using moment equation. Summation mb equals 0, which gives us A times 0.84 total distance minus 300 kilonewton load acting in downward direction and a reaction acting in upward direction times 0.42 meter distance from C to B equal 0 since B being in support. We get A equal 150 kilonewton. Now, using equilibrium equation, summation f y equal 0, we get A plus B equal 300 kilonewton. Then B equal 150 kilonewton. Beam being symmetric, 300 kilonewton load is distributed equally to 150 kilonewton in both support A and support B. Now, for bending moment, since A and B are hinged, moment is 0 at supports. At 300 kilonewton or point C, point load is acting, so bending moment will be linear. So moment at C will be 150 load at A times 0.42 distance from A to C, which gives us moment 63 kilonewton meter. Now, since we have support reactions and moment, we will draw shear force diagram and bending moment diagram. No axial force are present in this, so axial force diagram will be a simple line with no force. Now for shear force diagram. Here, load at A is 150 kilonewton acting upward. So 150 kilonewton, 150 kilonewton load, 150 at A will go linear to point C. 150 minus 300 kilonewton load acting downward gives us minus 150 kilonewton. So minus 150. The shear force diagram will change direction from negative to positive. Then it will go linearly to point B, and load acting at B is 150 kilonewton positive, so the shear force will go to 0. So this is shear force diagram. Now for bending moment diagram, we have support A and B. Support A being pinned has 0 kilonewton meter moment, and support B also have 0 kilonewton meter moment. The moment will linearly rises to 300 kilonewton point C. So 63 kilonewton meter we have calculated, and then again to be 0. 300 kilonewton being point load, the bending moment diagram will be linear. Now we will use Etabs to do this problem easily and fast. For open Etabs, use built-in setting metric SI Indian. For x direction, grid lines A and B for two supports we will use two grid lines, and in y direction we only have one grid line, and in z direction also we have one grid line. So in x direction 2, in y direction we have 1, and in z direction number of stories indicates in z direction in Etabs 1. spacing along x direction, total length of span 0.84 meter. Okay. Define materials, material of beam. So I will define material, add new material. I will use Fe 250 grade steel according to Indian code. Okay. I will define the section, frame, beam section. Add new property, steel. I will name it beam. Material Fe 250 as I have defined previously. Okay. Now I will draw beam from A to B. For this, draw beam from A to B. Now I will assign load to this beam. Select the beam, assign frame load, point at the mid, relatively 0.5, 300 kilonewton load, gravity, live load, apply. Okay, you can see 300 kilonewton load acting at the center. Right click it, loads, you can see 300 kilonewton at 0.42 meter gravity. Okay, now I will assign joint, restraint, hinge joint. So apply. Okay. You can see hinge joint. Now I will run it. I will save it as save. Now joint reactions, joints for live load, apply. Okay, here you can see 150 kilonewton load acting at support A and support B. Now for shear force diagram and moment, shear in direction 2 to apply in y direction, so direction 2 to z direction. You can see values, apply 150, negative and positive according to Etabs. You can change the direction as you have assumed it. Now for moment in 3 perpendicular to the reactions and loads, apply. You can see 63 kilonewton meter moment. Thank you.